Hello, Miss Tiffany. Good morning.
Hey, good morning.
Okay, so
I've been doing been trying to do my Khan Academy.
okay, so how the Khan Academy is going on?
I
Is
like
it?
it. Yeah, I like it. I like Khan Academy. I just you know, try to test my skills, and I'm just not really realizing I really need to do all of my math, like everything Miss Fantasia taught me. I like kind of I need to brush up on my math over anyway. So excuse me from the last time.
No, it's totally fine, and you should do this if you are not understanding any concept or if you are having confusion. You should just let me know. Or yeah, it's always good to let me know.
Okay, okay.
So I got the geometry spelling wrong. Okay, this is fine.
Let me move into geometry.
By the way, we'll be starting our class at 10:55. It's 12 minutes from now. So if you have any doubt or if you want to talk about something, we sure can.
Um, the work that you have given us on the worksheets on Google Classroom.
Yeah.
Do I supposed to email you that work, or do I just do it at home?
Yeah, what you can do is you can do it at your home and on your notebook, and you can click pictures and you can email me. You can upload it on Google Classroom. You can
Hmm.
text me. You can do anything you like. But the best way what me and Miss Fantasia can check your work is when you upload it on Google Classroom.
Oh,
Hello,
okay.
Mr. Darden. How are you?
Hey, Mr.
Good
Raymond.
morning. Good morning.
Good
How's
morning.
everybody?
All right. We still hanging on in there. I see him.
Oh yeah, I'm here.
That's good.
Yeah, we just started geometry today, huh?
Yeah, we'll be
Mm.
starting geometry. Hello, Miss Dawn. Good morning. Miss Dawn. Good morning.
Did you get my homework, Mr. V?
Oh, I did not. Where did you submit it?
To Google Classroom,
On Google Classroom. For which one?
decimal.
Okay, decimal. The word problems of decimal or just the decimals?
You had addition and subtraction.
Okay, yeah, I got it.
Okay.
Yeah, I just got it. I'll check it today and I'll let you know how you did.
Okay. Okay, so what are we doing today? Nothing.
Yeah, probably just we'll sit around. And today is pajamas day. So what? You already uploaded your photos or videos, or Miss Tracy already seen you all in pajamas. So what is it?
No. No, no. I'm not in my pajamas because I have workers coming
Um.
in and out of my building today.
Okay. So what about others? Miss Tiffany, Mr. Raymond, are you rocking on
Are
pajamas?
you in your pajamas, Mr.
I
V?
don't I don't wear pajamas.
Yeah, me
Uh-uh.
too.
Uh-uh.
I don't like pajamas. I seriously don't. I'll wear anything other than pajama. I can wear a skirt, but I won't wear a pajama ever.
No, I sleep in my underwear.
No, that's fine.
What is
I'm
that?
good. I'm good.
Yeah.
It's all the idea of Miss Tracy, so I'm good. But yeah, the point is that it's a funny day. So we still have 9 minutes. So let's give everyone 9 minutes. You all can have your 9 minutes. You can eat something, take your time, and then we'll start the interesting geometry.
Mr. V, is,
Yes, Miss. Yes, Miss Dawn.
is geometry like science?
Sorry.
Is geometry like science?
Yeah, geometry is not like science, but it's one of the most historical mathematics. The first thing humans noticed was geometry. In the Greek
Oh,
Empire, if you learn about history, geometry is everywhere. Like the first thing
oh,
anyone noticed is geometry. Yeah.
oh, okay.
Yeah. So okay, let me show you. Uh, okay, so I hope everyone can see this big picture. If not, I'm zooming it out a little so you can see it better. Where did it went? Okay.
I can't see it.
Yeah, just wait for some seconds. You'll be able to see. Okay. Okay. So I hope. Are you able to see it now?
No,
Okay. So what are you? What is on your screen? Just geometry?
I see it.
no, just a brown speck of a paper.
Okay. So that's good. So that's what we want to see. So what you are seeing is the earliest Greek paper on geometry. The paper is dated on 1636 in London, but it is printed at 1636. But this whole set of papers, what we are seeing right now, was developed in 1400 in Greek. So what they are doing, what their engineers are doing is measuring angles. In the second image, you can see they are measuring angles and finding lengths of objects, big objects. So, and in 1300s, they used geometry to find distance between cities. So they predicted, so the distance between two cities of Greek today is almost 500 miles, and what they predicted was 515 miles. So they got just a small error of 15 miles. They predicted the value of distance between the cities so accurately. And what they had what just sticks, and that's it. That's pretty much it. So,
Could you make it bigger?
sorry.
Could you make it bigger?
I made a bagel.
Could you make it bigger?
Okay, I can make it bigger. Yeah, yeah, yeah. I can.
That's right.
Hello, Mr. Dwayne. Good morning. So Miss Dawn got disconnected. I hope
Morning.
she comes back and see it bigger. Can you all see it comfortably? The image.
Yeah, I can see it.
Okay, so this is just
Yeah,
what
I
I'm
can see it.
saying. The geometry is way old and it is quite basic.
Okay, the way, like I said, the way of geometry being this
Okay, so Miss Dawn, can you see it bigger and better now? Miss Dawn, can you hear me?
Yes.
Okay, can you see it in a better way?
No. I can't see, it's too small.
So can you pinch it like what we used to make it bigger?
Never mind, I got it.
Okay, good, good, good.
Okay, what is all this? I speak English. I don't know what this is.
So we are not meant. It's not meant to be understood. It just means that geometry is way older than the all of the other mathematics. So we are studying one of the basic principle of mathematics, which way earlier people understood. So this will be easy.
all geometry is used for all the different things. Engineers, architects.
Yeah,
Hey, where'd it go?
yeah. So I
It's gone
deleted
now.
it. I
The
deleted
picture's
it.
gone. Oh,
Yeah,
okay.
because
It's gone.
yeah, I deleted it because we have another picture to see.
Okay, now you want me to play with these blocks? What's happening?
Ms. Dawn, just because these pictures are too large, so just give me some seconds to make them a little
I
smaller.
got it. I got it.
No, just give me a second because I am adjusting the image right now
Okay.
for everyone to see it clearly. Okay, so I hope everyone can see this clearly. Can everyone see this clearly? The image?
I see it.
Yeah, I can see it. Yes,
Okay.
I can see it too.
Yeah, I can see it.
I got it.
Okay, so start the lecture. So what I'm told is I have to take attendance for you all. So if you all can hear me, what you have to do is to open the chat box and write your initials. Like I am here, so I got VD. So that's it. That's what you have to do. So can you all please do it for me? Okay. Miss Dawn, I thought you are DH. So no proxies are allowed. If you are DH, you are supposed to write DH. You are not supposed to write for Mr. Doing. Okay, so that's it. Nice. So what we see in this diagram, I hope everyone can see this diagram clearly. So this is just some basic diagram. What we are trying to see here is the division of a shape. Here, in this shape, the first shape, the rectangle maybe, or maybe square, we don't know. So let's suppose this is a
Did
rectangle.
did you take it off the screen?
Sorry, Mr.
I
Dwayne.
don't see it. I don't see it. Did you take it off the screen?
Yeah, I took it near geometry, near the heading geometry. You can find it.
I see it. I don't see it.
Okay.
And he can't see it.
You're
I
not
can't see
able to
it.
see it, Miss Tiffany?
He can't.
No.
No. Dwayne, not Dwayne. Oh God.
Raymond.
Raymond. Mr. Raymond said he can't see it.
Okay,
I see it
Mr.
now.
Okay, you
I
got
see
it
it.
now? Yeah. Okay.
Yes, I see it.
So we are looking at the first square or rectangle.
Mm-hmm.
Probably someone's mic is on, so there is little disturbance.
Oh, my.
Yeah, turn our mics off.
Okay, thank you.
Mr. V, what am I looking at?
So you are supposed to look at some picture of triangle, squares, and circles. So are you able to see the picture?
Yes.
Okay, good. So in the first diagram, what this whole diagram, the first row, what this illustrates is division of shapes. So how we divide shapes equally, what we mean when we divide shapes equally is it is just some basic concept. So it means that we are dividing them by area. Notice in the third box, all three have equal areas, right? In the fourth box, all four have equal areas. Similarly, in triangles, all of them are divided in equal areas. Yes, Miss Dawn, please go on.
Okay, what does equal mean?
Yeah, what does equal area mean? Yeah, I'll come to that. Good question. So in the circle as well, what we see is they are divided in the second circle. The circle is divided into two parts. So when I say it is divided into two parts, what I mean is it is divided into two parts of equal area. In the third circle, it is divided into three parts of equal area. And similarly, in the fourth circle, it is divided into four parts of equal area. Now let's understand what the area means. So this is what we are covering is pretty basic. I'm going to delete the diagram and we are just overviewing what is area.
Put it back up. I can take a
Okay.
screenshot. There we go.
Yeah, sure.
I got it. Okay, I got it.
Okay. Okay. So the basis. So this is just a basic problem. Why I am covering is why I covering this is because this is one of the basic geometry problems which appear in the paper in the exam. So if we have this and we divide it into we have to divide it into three equal parts, or suppose four equal parts. What we do is, this is simple, right? This is a pizza. This is like a pizza. So when I do this, I divide it into half. And when I do this, I make it into four equal parts, right? This is how we learned it in the fraction. Now, and in the fraction, we also learned it. What if I tell you what this part represents? So this part represents 1 over 4, right? 1 over 4, right? Because there are four similar parts like this. This one is one of them, and these two are other parts. So when I talk about this part is equal to 1 over 4 of the whole, right? So what is this 1 over 4? This 1 over 4 is 1/4 area. This whole have some area, and this is 1/4 of the total area. So these are some basic problems. We will continue to learn about the areas more in the later lectures. So this is one of the problems I just want to introduce in the front of the lecture. So we'll move on to the. Yes, Miss Dawn, please go on.
How do you spell area?
Okay, how do we? This is important. How do we spell area? It is A-R-E.
He said area. That's what he's saying, area.
Oh, okay.
And please pardon my pronunciation.
I can't see it.
No, that's how he pronounced it. That's part.
All problems solved. I did not know what you all just said together, so it kind of
It
makes.
must, Mr. B.
Yes,
Okay,
Miss Dawn.
you said that's 1/4. Okay, so how am I supposed to find the area from 1/4?
Yeah, so for now, you're not supposed to find area for 1/4. What I'm trying to say is when you see 4 parts, in the fraction we learned this, right? When you see 4 parts, what we say of one part, that it is 1/4, right? That's what we learned in fractions. So what I'm saying is,
Right.
what this 1/4 means is area. This 1/4 is 1/4 area of total area. So don't stress over this example much because
I don't understand this. I don't. I'm still not understanding.
yeah, it's okay if you don't understand it. This was just some introduction. We are going to cover this in the later part of the lecture, so don't stress over it at all. So we are going to cover it anyway. Okay. Okay, so let's move on to the sum parts. So there are some vocabulary we're going to use in geometry, some basic vocabulary. One is point, one is line, line segment, and the other is ray. Okay. So how we define point is just a point. That's it. So suppose, okay, be ready and don't be, because lots of light is going to come into your screens now. You will see the face of the most popular human being on earth in few seconds. Da-da! Can you see me all?
I don't see a picture of me.
Okay, you can't see my video?
No, I don't see nothing but point
I see nothing but green screen.
Okay, it's okay. So let's try another thing. Okay, it's fine. So let's try what the point is. I was going to show it on my video, on my face, what a point is. So suppose we have a square, right? You all are familiar with a square. And if I say, suppose this is a football ground, okay? So a soccer ground, sorry. So this is like a soccer ground. Okay, and this part, the right part, belongs to team A, and the left part belongs to team B. Now if I am standing somewhere in the side of team B, what I say is how I describe it in the terms of the map. So I say I am somewhere here, this red dot. So this red dot is known as point. Now this point is in the side of B, right? So if I say the red dot is me and I give you this map, you can see me, right? You can say that, okay, Mr. Vipul is standing in the side of B and somewhere near the middle line. When I say that red dot is me and I am standing here, so you will know that I am standing in the A side of the A goal. I am standing near the goal post of side A, right? So this is point. So how I represented myself is by a point. I hope that's clear, right? This is some basic concept of what a point is. A line. So let's define what a line is. So the line is defined. Yes, Ms. Dawn.
None of this is clear to me. None of this is clear to me. Not a word.
Okay, it's fine. So let's go back to the point. So if you are talking about this 1/4 in area, just forget this one, because I saw a problem today in the paper and I thought that let's introduce it first. But it's okay, we're going to cover it in the later part of the lecture, so don't worry about that. So if you are focusing on what a point is simply a location on anywhere. So if I draw this, so this is a point, right? I made a point anywhere, any location, and I just pinpoint my pen on that part. That is a point. Suppose when we were children, at least this is true for my case, whenever the guests come in the home, my mother wants, when I was 1 or 2, my mother wanted them to show my abilities and asked me where my nose is. So what I did was, I pointed my finger at my nose, right? I put a point, I place my finger on the nose, and I say this is my nose, right? So how you identify anything? You put a point on it. When I say you identify where is your eyes or where is your lips. So what you do is you place a finger on your lips, right? So that is how we find things in the geometry, in the map. So suppose if I draw this square, okay?
Also, basically, geometry is more or less consistent about area, like on land.
Yeah, so geometry is more about the objects we see and the properties of objects, basically in real life. The properties of objects.
Okay.
That's it. That's what the geometry is.
Okay.
Raymond. Mr. Raymond, could you repeat that?
Sorry?
Mr. Raymond.
Now, what I say is that geometry is the study of the area. When you study the area, as far as
so geometry is, area is the part of geometry.
You mean like the area around me? Is that what you're talking about?
no, it could be like on a map or something like that. But I don't know. I don't know exactly what it means. I'm just guessing. Basically, I'm going by what he's showing. I'm just coming to a conclusion.
It's fine.
Okay, Mr. B.
Yes, Ms. Dawn.
Are you talking about like the area around me, or what does that entail?
Yeah, so what I'm talking about is the things around you. We take the things around us and we find the properties of them, like my lips, my nose. So when I point my finger at my nose, I say I made a point, right, on my nose to identify my nose, hence the word point. Now, Ms. Stephanie, yes, you were saying something?
From the last session that we did that Ms. Fantasia had gave us, I don't know if Ms. Dunn was around, but I think you remember when she was teaching us the areas and the points and stuff, we had the graph, Ms. Dunn. and we had to like pin it like point it out, and we had the negative and the negative and the negative and the positive. It's something
Right.
similar like that. It's something similar to like that, Miss
Okay.
And
Thank you, my Miss Stephanie.
you welcome,
Thank you,
mommy.
Miss Tiffany.
Uh-huh. That's
Okay, so that's what I'm saying. So, if I have a square, and if I say you that where is the right upper right corner? Upper right corner. So what you all will do is you place a point in the upper right corner, right? Like this, that this is the upper right corner. So what you did was place the point to identify the location. So this is point. So eventually you will get what a point is. Let's move on to what a line is. A line is an we all know what a line is. Okay. Mhm. Okay. So this is a line.
What is a line? A line is just a straight,
Yeah, a
like
line is
you
a line.
pointing to something. Like you pointing to something.
A line is just a line.
Yeah, we can't define it more. A line is simply a line. You cannot define it more. You cannot define it less. We all know what a line is. It's a straight thing going on and on and on. Now, in geometry, line is never ending. Okay? So, how we represent a line is we make a arrow like this and an arrow like this at both the ends of the line whenever we see one, and we say that this will go on forever and ever, and this will go on forever and ever. This side will go on forever and ever, and the left side will go on forever and ever. So this is a line. So a similar example is railway tracks, right? So the railway track line, it end I know it ends somewhere, but if we stand at a railway track, what we see is that this line goes on forever and ever, and I can't see the end of it by my eyes. So this is how we define a line. A line in geometry is forever, it doesn't end. Okay? And how we name the line, because this is a line, right? And I have to name this line. So there is also this line. So what if I have two lines like this? I have to name them, right? So what we do is, in real life, how we name lines, we find the station, right? Suppose this is Ohio. Okay, I'm not good with the pronunciation of Ohio or Ohio. Suppose there is a station on this line, blue line, O'Hare, and there is this station on this again blue line, Racine. Okay, and there is this station, Cottage Grove, CG,
Okay,
and
that would be the line segment.
sorry, Mr. Freeman, yes.
Are them the line segments?
Yeah, so we are still studying about lines. So what is lines? So these lines are infinite. Like this, both ends go on forever and ever. So we call this a line. This is as simple as this. So we are not studying something complex. We are studying some basic things. So don't think too much about it. It is just as simple as a line. That's it. So if
All
I say
right,
there
all
are
right.
two stations, Cottage Grove and Madison Street. So how we name this line? This line is named as O'Hare to O'Hare and Racine, and I place a line symbol in on the head of it and make two arrows suggesting that this line is infinity. This will go on forever and ever. So this is how I name line. This is how we name lines. Yes, Miss Dawn, let me just complete this one and then yes, I'll be able to hear you. So this is cottage grove and this is medicine, and how we write line is we place a symbol like this. This is how we name lines. Yes, Miss Dawn?
Okay, you gotta put uh where the line is. Is that what the OR is?
Yes, we
Why do
have
you
to
have
put,
to why do you have to name these lines?
because we have to identify the line, right? If I have to say what is the upper line, so you have to give it a name, right? We all have names to identify ourselves, so the line should have a name,
Right.
right? Yeah.
Okay.
So this is why we give line a name. This is some basic simple things we are understanding. So what is a line segment? So a part of line, when we cut some part of line, we call it line segment. Okay. So segment is something which we cut off from the main line.
Can't you say line fragments too?
Yeah, line fragment is also a correct word, but you know, someone came at the first in the 1600s and called it line segment, and now we have to call it line segment. Otherwise, I would have called it, you know, something funnier. But here it is a line segment. So if I divide this, you know, cut this line in this way, so I make this a point. Here a point, let's just call this point a Q, and here there is a point, let's just call this point P. So this is where we use points, right? We place 2 points on a line and we say that cut the line segment between those 2 points. What we got is a line segment from Q to P. And how we define this line segment, how we write the name of this line segment, we say QP and we just make a line. We don't use the arrows because this does not go on forever and ever. Hence we just simply write this way, QP. I hope you all understand what a line segment is, right? A line segment is just some part of the line that we cut off. So we cut off Q to P and this line segment is this. Now what is a ray? Let's study about a ray. So a ray is like sun ray. What I heard the most about is a sun ray, right? So how the sun ray works? So this is a sun. Okay, this is a sun, bright sun. So how the ray goes is it starts from the sun and it goes on forever, right? And it goes on to Earth. It goes on to Jupiter. It goes on forever, right? So this is how a ray works. A ray have a starting point. A ray have a starting point. Let's call this point Q, but it goes on forever. Okay. Now suppose if this have a point R. What we can call is, how we name this is QR. We start with nothing, but at the end we have to make an arrow because it goes on forever in the side of R, right? So this is how we define ray. Okay, let's see. Okay, yes, Ms. Tiffany, please go on.
When you did the Q and R, do we need to put the dot or just leave it empty?
Yeah, In the on the Q side,
Yeah, just leave it
yeah,
empty.
you can put a dot,
Uh,
and but usually on the paper you will see it empty. But it's fine if you put a dot. It's fine. It is a conventional way to put a dot as well. But usually you will find this without a dot.
okay, okay.
Yeah. Good question. Okay, so moving on, let's see if you can identify what this is and write the name for this in the chat box. Okay, choose the options because you cannot write in the chat box, so let's choose the options. Okay, so this is option A, this is option B. Yeah, so whoever wrote in chat box, I have not completed with the options yet, and this is option D. Okay, Mr. Dwayne, Miss Dawn said, I still don't understand. Okay, so Miss Dawn, what you do not understand, if you can say it to me. Okay, Miss Tiffany says C, Mr. Dwayne says C. I'm waiting for Mr. Raymond. Okay, Mr. Raymond says C. Okay, so this is simple stuff, right? So, and how we write a point is we just simply write it as Q. That's it, right? So if I have a point here named as Q, so this is simply written as Q. Nothing more, nothing less. Okay. Now, a point may have several lines going through it, right? Suppose I have a line like this, and suppose I have a point here known as P. So there might be another line. Okay, I'm not good with lines. Let's see if I can make one. Okay, perfect line. So if we have P, we can have multiple lines going through a point, right? So now if we have Q, and now this we have R, and suppose we have S. Now when 2 points share a line together, we call them as collinear. You can write this word in your notebooks.
Collinear.
Yeah. Okay. Mr. Raymond, there's some disturbance from your mic, so can you please mute it? Thank you. Okay. So collinear. So what is collinear? When 2 points share a line. When 2 points share a line. Okay, I don't know what is happening, but you get it, right? 2 points share a line. So here, Q and R are collinear. The point Q and R is on the same line, right? So these points are collinear. Q and P are also collinear because they are on the same line. P and S are also collinear because they are on the same line. Now please write in the chat box, is Q and S are collinear? So I'll write the question for you here. Q and S are collinear or not? So Mr. Dwayne says no. Ms. Stephanie says no. And Mr. Raymond says no. Miss Dawn, are you here? Can you hear me?
Connected.
Miss Dawn? Miss Dawn?
Disconnected.
Okay. Okay, I hope she comes back again soon. So this is about collinearity. So you will hear about collinear points again and again in the whole geometry. So now we'll move on to an important concept known as angle. Okay, and again I'm not very sure about the pronunciation. I think it is pronounced as angle. Yes, Ms. Stephanie, please go on.
I guess I'm acting like Miss Dunn everywhere. But how would you write it? How would you write it? Like if you were to write the collinear line, is it a certain way you write it? I mean, I know you said that's how they share the same line, but when you were showing us from the last example with the arrows and the, without the points and everything, how would you write it?
Okay, so there is no proper vocab for writing how 2 points are collinear, but we simply the question will ask you, or you are simply to find if 2 points are collinear. So how you write it is Q and S are collinear. That's it. So
it won't be you have to draw no arrows, lines or anything.
Sorry, I don't understand. Can you repeat again, please?
No, I was asking. So we don't have to draw lines, like we did with the line segment.
Yeah, you don't have to write lines over them because they are points, right?
Okay, that's all.
Yeah, it's okay. Thank you.
This is Vipul.
Yes, Mr. Green, please go on.
Are you saying that Q and P are colines?
No, what I'm saying is Q and P are collinear points. They share the same line and hence they are collinear.
It would be Q.
I just marked it down as Q colines, so.
No, it's collinear. Miss Dawn, I'm coming to you. Yes, Miss Tiffany?
The way you just said it was just Q and S does not share. Okay. What I'm trying to say is, so it won't be Q, P, and R. Will be S because they all share the two they share the same line. Okay, so Q and S don't share the same line.
Yeah, and so does R and S. R and S don't share a line together, right?
Okay. So it can't be. Okay, I get what you're saying. Okay, I get it.
Okay, yeah, fine. Yes, Miss Dawn, please go on.
Okay, all this stuff gonna be on the test? Like, do I have to draw lines on the test?
No, the test will give you a diagram like this one that we drew over the board, like this one, and they will ask you, are Q and S collinear? So the answer will be no, they are not collinear. That's it.
Okay, you're gonna post this to Google Classroom, right?
Yeah, I'll post it to the Google Classroom. I'll post some questions.
Okay, do you have any like references where I can go and look this up and try to understand it better?
Yeah, I'll post some concept material too, so you
Okay,
can.
yeah.
But this is pretty.
Okay.
I think this is pretty basic stuff. You will understand it very easily once you look at.
Yeah.
So no problem. So now let's move on to
Okay,
the
thank
angles.
you.
Yeah, thank you, Ms. John. Okay, so angles. Now, how we define angles? What is an angle? You all must have heard about angles a lot, right? So suppose this is a ray. Okay, this is okay. So suppose its name is Mr. Raymond. This starts with R and it have a point D in it. Okay, so this is a ray. Now suppose there can be another ray from the point R, right? Suppose there goes another ray from point R and it has a point N. Okay. Now notice that it looks like open book or some notebook or something, right? So this both the rays, how we write rays is RD and RM. So both of these rays originate from R. So how we call this angle, this this open part is known as the angle between the rays RD and RM. This part is known as the angle. So how we define the angle, what we say, how we name the angle is, this is the symbol. This is the symbol for writing an angle, and we take one point in one ray, we take the similar point, the common point on the second place, and a point in another ray. We write is at DRM. Obviously, we can start from the second ray, we can start from the M. In the second place, we always place the common point. The common point in both the rays is R, right? So we place R in the second part, and then we take the point of the another ray. So a point in another ray is D. So this can also be written as angle MRD or angle DRM. Okay, let's take another example and show me what you see. If I have a ray like this starting with P and going on forever, and there's a point R, if I have a ray another together starting with point P and have a point R, so what is the name of this angle? So write in the chat box, and I am assuming that you have to start with this sign. This sign is for angles. Okay, this sign is for angle.
So you got a R, a D, and a S, or
Okay,
the R, P,
it's a P.
D.
Yeah, this is a P, this is a R, this is a S. So write the name of this angle in the chat box. Is Miss Tiffany and Miss Green got the answer? Mr. Riemann, I'm waiting for your answer. Can you hear me? R. Okay, so uh, I don't know why you wrote L. Okay, so the simple thing is we take one point from one ray. So let's start from this R. Then we take the common point in the second place, and then we take a point from another ray. So this is angle RPS, or we can start with S, then write P, and then write R. So yes, Miss Tiffany, you are correct. Mr. Dwayne, you are correct as well. Okay, Mr. Dwayne, you wrote RSP. No, it should not be written as RSP. In on the second place,
Yeah,
always
I wrote the I messed up because I ended up hitting the S before the P, but it is RPS.
yeah, it should be RPS or SPR. Okay, yes, Mr. Raymond, you wrote this one correct. Okay, so that's how you write the name of an angle, right? Now tell me by intuition, if I take two angles, I start with P, let's just name it Q. I take another ray, let's just name it S. I take another ray, let's just give this name. So we have two angles. Okay, I drew this. Okay, so these are two angles, right? We can say angle QPS. So we have angle QP. So I won't be writing two names for every angle, so I'll just be writing one of the names. But remember, both of the names are correct. Someone was saying something? Okay, so we have two angles QPS and angle BAC. By intuition, what do you think? Which angle is bigger? Which mouth is more open?
QPS.
Yeah, you can write. Yeah, QPS. So by intuition, we all can say it's Q. Yes, Miss Tiffany, you are right as well. So it's QPS. So we say that angle QPS is greater than angle BAC. Okay. Now we use some measurements for measuring the angles. Okay. We have a scale, like, because we measure things, like, right? So we measure things from, this is 1 centimeter, this is 2 centimeter, this is 3 centimeter. But how do we measure angles? So what we do is we measure angles in degrees. Okay. Now suppose this is a straight line, this is a horizontal straight line P, and this is a Q. Now see, what we do is, you have all used a protractor, right? So we place our protractor here and we measure this and we write it in degrees. So suppose I'm just taking an example, this angle can be equal to 30 degree. So what we say is, how we write it is angle RPQ is equal to 30 degree. Okay, so pardon my drawing of RPQ, but what I tried to write is angle RPQ is equal to 30 degree. So now as this angle increase, so if I put my hand, I grab this ray, and I try to rotate it. What happens when I try to rotate it? anti-clockwise. The ray PQ stands where it is, and the ray PR gets rotated to anti-clockwise, and it's rotated like this. Okay, this is a perfectly straight line. Now when I rotate this, I increase the angle, right? You all know this. Now this mouth is more open, so I say I have increased the angle, and now the angle looks something like this. And now suppose I say now the angle R, I can say it is increased from 30. I don't know how much, but it is sure increased from 30, right? So let's just say it that now this is equal to 90 degrees. Okay. Now what if I grab it again, I grab this ray again, and I rotate it further. I rotate it more than 90 degrees. So I make a ray like this. Okay. Now the angle is more, right? I have further increased the angle. Okay. Now this is greater than 90 degree, right? Let's say, so I'm taking just an example of some number greater than 90 degree. So the greater than 90 degree, let's say it's 120 degree. Now the angle is 120 degree. So now I further rotate it again and again till I make a straight line. Imagine you are doing this with your notebook. So you open your notebook, so you open it a little and made a 90 degree, then you are opening it a little, and then you again rotate it anti-clockwise, and now you have opened your notebook completely. So what happens when you open your notebook completely is they all become a line. Now the ray PR and the ray PQ made a line out of each other. So are the points R and Q collinear or not? Yes, Ms. Stephanie, please go on.
So after the degrees, okay, so now that it's flat, so would it be just considered as a line?
Yes, now this is flat, so this is a line actually. Okay. Can you all see that this is a line? So what, can you name this line for me? So this line can be written as
RPQ.
Yeah, RPQ.
But it won't have no, yeah, just like, okay. I thought about it being in the middle. So it's just RPQ without the arrows.
Yeah, so it should be RPQ with the arrows because this is infinite, right? The rays go on forever. So the ray in the left of the R will go on forever, and the ray in the right of the Q will go on forever. So this is basically
just a line. Because it's just a line.
Yeah, this is just a line.
Okay, I was still looking at the lines, the two dots, the two lines in the middle on the side. Yeah. But yeah, so, okay, I get it.
Yeah, they are just points because we have to name them, right? So they were rays once, but I made the ray RP rotate anti-clockwise till this got flat, like your notebook. When we open our notebook, we can place it to be flat, right? And now, can you all say R and Q are collinear or not? Can you write in the chat box if the question is if the R and Q is collinear or not? Okay, so yes, Ms. Tiffany says yes. Mr. Dwayne says yes, they are. And Mr. Raymond says yes. So yes. Now, when, so in the start, when there was just PQ and there was no ray to compare it with, the angle was 0, right? Because there was nothing, there was no angle, so the angle was 0. And when I drew something, a ray, so the angle became something. We started with saying that it is 30 degrees, but this was something positive, right? More than 0. Now understand this, we still have an angle, right? We start from the ray PQ and we end with the ray RP, right? This is how we define an angle. So whenever we have a straight line and we want to find the angle in the straight line, the angle is always, so the angle, let me just erase this. So the angle RPQ, when RPQ make a straight line, the angle is always and always equal to 180 degrees. Write this in your notebook. Whenever RPQ forms a line, the angle is always 180 degrees. Okay? So please write this because I have to move this. So whenever two rays make a line, then the angle between those two rays is equal to 180 degree. This is an important concept. Now, I'm not still satisfied, so I keep rotating this. Okay, so I keep rotating this ray. So I can still rotate my notebook, right? Once my notebook is flat, I can still rotate it, right? So let's say I rotate it to this point. So what happens when I rotate it? Oops, sorry. Okay, so there was this P and there was this Q, and now this is an R, and I say the angle like this. Okay, so now this angle should be more than 180 degree, right? Because I have rotated it more and more, so this should be more than 180 degree. So what I say, let's just taking an increment. So this is 220 degrees. What I say, the angle RPQ is equal to 220 degrees. Okay, but I'm still not satisfied. Let's go more and find out where we can place this line till. So I hope you all are understanding what we are doing. We are just rotating the ray PR anti-clockwise, and now we rotate it till almost when it matches. So what I did was, this was the line ray PQ and this is the line PR. Now they are almost together. What I did is I flipped the notebook, okay, completely to make it, when both the pages are touching together inwardly. The front and the back of the notebook are touching together now, almost touching together. So when they actually touch together, when they are, because this is almost, right? Because I want to show almost. Why? Because we are not able to distinct if they are actually touched together. So when they actually touch together, the angle is 360 degree. Okay, so how we divide the angles between them? So this is Q. So I'm just giving you a recap of what we learned. So this is Q. Now whenever this Q have a straight line like this, okay, these are two straight lines, this angle is called as 90 degree. Okay, now whenever I have this line, so this whole angle, because it is now a straight line, this whole angle is known as 180 degree. When I further make a line like this, I add another 90 degree to this 180 degree to make it 270 degree. You have to remember this, okay? And this whole angle, the whole circle is for 360 degrees, okay? So if you have any doubt of what we did, raise your hand. So, I can repeat this again or I can clarify. I know this last part might be a little confusing, but what I'm trying to say is just imagine your notebook. When we open our notebook, we start with 0 and then we slowly increase the angle from 1, 2, 3, 4, 5, 6 till 90 degree till we make it like a L. When we make a shape like L, the angle between the notebook is 90 degrees. And when we make the, yes, Miss Tiffany, let me just complete this quickly. So when we make the notebook as a straight line, the angle is 180 degree. And when we make a reverse L, the angle is 270 degree. And when we flip the notebook, when we make the cover and the last page touch together, the angle is 360 degree, and that is the maximum angle. Yes, Miss Tiffany, please go on.
Can you draw or show me the two? Is that 270, 260, 270?
Yeah,
Can you,
270.
can you
Yeah, sure.
draw that one by itself? Because I'm trying to write it down and make sure I got it correct.
Yeah, sure. I'll do that.
Thank you.
So this is a horizontal line. So this is like an inverse L. This is P, this is Q, this is R. And please note that writing this part is important. When I draw this almost circular thing, so this is important. So what we are trying to find is this angle, okay? This is angle QPR. Okay?
That would be the 270 angle.
So this is 270.
Okay. I just want to make sure. So it's the opposite of 90 degrees, of course.
Yeah, this is now everyone please concentrate on what we are seeing. This is opposite of 90 degree, right? And because I know this complete angle, when I draw a circle, if I draw a circle like this, this whole circle is 360 degree, right? When I rotate the R and touch them together, this is 360 degree, right? So now I have started with 0 and I went to 270. How much more angle is left? How much more angle is left to cover? So the total angle was 360 and I have come till 270.
90
So
degrees.
so the angle left to cover is 90 degree, right? Notice
Right.
that this part, okay, notice that this part looks like a L, right? Looks like what we did in 90 degree. Just this part. Does it look like 90 degree? Yes, right? Because this is an L in itself. So what happens? Two angles are always equal to 360 degrees when we see them as inner angle and outer angle. So this outer angle in the black, QPR, the outer angle, is equal to 270, and the inner angle is 90 degrees. So notice that we can do the same thing. So this is an interesting concept, right? So let me clarify this again. Okay. You all can see the new diagram, right?
Yeah.
Yeah. So if I make this as A,
Yeah.
and if I make this as B, and if I make this as C, now when I ask you that this is a perfect L, right? And when I ask you what is this angle, so you will say me this is 90 degrees, right? But when I ask you what is this angle, the angle in red, what is this angle? So what you
Stand
will
like
do,
270 degrees.
yeah, so what you will do is subtract this 90 from 360 and give me the answer. So the answer will be 270. Okay, this is
Right.
270. So the summary of this is every angle is 360 and you can divide the angles in 360. So this is 90 and this is 270. So the whole 360 is divided in two parts, 90 and 270, right? So let's take another example. Okay.
Mr. Smith, Sophia, when you say, so do like when we do the angles, do we subtract each one or do we divide?
No, we subtract them
Okay, okay.
with 360. So understand what the concept behind subtraction is. That I know that the total angle when I touch my notebook of front page and the last page together, it makes 360, right? And when I turn it in as the inverse L, like the inverted L, I say that I have turned it till 270 degrees. I have completed 270 degrees out of 360 degrees, right? So how much more angle is left to cover? 90 degrees more to go, right? And
Right.
hence we call this angle the left, so I say the 90-degree more is left. So this angle is equal to 90 degree because I have to cover 90 degree more now. Okay. So let's take another example and let's see if you all are clear with what we are doing. Okay. So if I say this as C, if I say this as B, if I say this as A, and if I say that this angle is equal to 30 degree. Okay. This angle, the angle in black, is equal to 30 degree. Now if I ask you that what is the value of angle in red, what is the value of angle in red, write in your chat box what do you think is the value of angle in red. It is just simple. You have to think that the whole circle is equal to 360, the black part is 30, so what will be the red part equals to? Okay, Mr. Dwayne wrote the answer, Mr. Raymond wrote the answer. Okay. Okay, yeah, it's fine. So Miss Tiffany, what we are doing is, what I'm saying is, so try to understand it in the practical way. We can see this in the practical way of how we look at things. So suppose I have this ray, okay. The ray is AB, and I have another ray which is A and C. Okay. Yes, Miss Tiffany, please go on.
Oh, what I did, I was looking at the angle and I was subtracting it. I subtracted 30 from two from wait. Yeah, I was looking at the red and I subtracted 270 from 30. That's how I got 240. But I see what you did. It ended up being 30, 360. Okay.
Yeah, so you
But
have to
see,
subtract.
I was looking at it because it was a. Well, I know you say subtracted from 30. Okay, I was looking at the angle, so I was looking at the 90 degree and you know what I'm saying, like the angle in that way. I get it
Yeah,
now.
yeah, I understand. So
I
what I
get it
meant, yeah, so what I meant by whole of this is that a circle is equal to 360. The whole circle is equal to 360 degree, and
Okay.
I
So
took just,
I'm sorry. We're always subtracting whatever number it is from 360.
yeah, we always subtract from 360 because the
Okay.
whole circle is a 360 degree. So these
I
are
got
all in, yeah, and again I would like to, just say that this all are in degrees, right? So the answer will be in degrees. So this will be 330 degree, right? So this is it. Now let's look at some of the categories of what the angles mean. So this is a 90-degree angle. Okay, you will use this 90-degree angle a lot in geometry because this is something special, right? We see 90-degree angles a lot of time, right? So let's say our buildings. So how the buildings are, what is the angle of a building? Suppose this is a building, right? And this is a street. So what is the angle between a street and a building? It is 90 degrees, right? Because it looks like a L. So I don't know what is happening to my drawing. Let's, try to draw a little better. Suppose this is a street. This is a horizontal line. And suppose this is my building. Okay, I know the second line is, okay, this is a building. So if I ask you, what is the angle, what is this angle, what is the value of this angle between street and building? So you will say me that this forms a L, so the angle is 90 degrees. Okay, so whenever we find the L, the angle between the horizontal and the L is 90 degrees. So what we call this angle is right angle. So please write this in your notebook. The angle of 90 degrees is known as right angle. Okay. Now you all have seen the Leaning Tower of Pisa. We all have heard about the Leaning Tower of Pisa, right? So the Leaning Tower of Pisa is a building which is little tilted, right? So what is the angle between this building and the ground? Is it less than 90 or is it more than 90? Please write in the chat box what you think is the angle between the Leaning Tower of Pisa and the street. Is it less? Is it more than 90? Yes, so Mr. Dwayne and Ms. Tiffany got the answer. Mr. Raymond thinks that this is less to perfect. So this less angle, the angle which is less than 90 degree, is known as acute angle. It is pronounced as acute, but you can remember this because this is a small, this is acute angle. Okay, this was a bad joke, right? Okay, so forget it. So the point is that this is acute angle. So any angle, so this angle is less than 90, right? So 90. So this means less than 90. So less than 90 degree is acute angle. Now a laptop, what do you think about the laptop? So I keep my laptop this way. So all the keyboards are here and all the screen is here. So I keep my laptop this way. So this is more than 90. Okay, as you can see, this is greater than 90. So how you write? So what you say to the greater than 90 angle is obtuse. OBT, obtuse. OBTUSE, and angle. So write the angle as it is. Okay. So I hope every one of you is clear about. These are the three types of angle. Okay. Now let's. So everybody, I hope everybody wrote this down already. So I'm moving on to lines. So there are two types of lines. Okay. Now whenever you see.
I'm sorry, Mr. Vipul, I supposed to raise my hand. So the last one is a greater angle.
Yeah, it is greater than 90. Yeah.
All right.
So it is known as obtuse. I hope every one of you takes a water bottle with you. A water bottle is with you right now. So whenever you are in class, because it is important to keep yourself hydrated. Okay. So have your bottle of water with you, and no alcohol in the class.
Coffee.
Sorry, yes, Mr. Dwayne, you were saying something?
I said I got my coffee.
Okay, but yeah, the point is if you get something interesting, you have to share, and I'll come to your home. I won't care about social distancing. If you are drinking something fun, I'll come there and I'll share it with you. So beware of letting me know. Okay? Yeah. So let's move on to lines. The okay. So type of lines. So what I told you that this whole thing, the right angle won't leave you easily in geometry. So this is interest. So this is a right angle. Okay. So this is 90 degree. Now this is an important thing, and this is, if you get this question wrong, it's totally fine, because I am going to teach this question in the coming lectures, but I just, because this is just some funny part, so we can do it easily. Now we know that the sum total of the angle in a line, in a straight line, is 180 degree, right? When I say what is this angle, you will say me that this is 180. Right? This total angle of a line is 180. Now, in this problem, you have a line. So let's name the line as probably P. Let's name this point as Q, and let's name this point as R. So this is a Q, okay? I messed this up. So this is a Q. This is another ray, Q. Let's just name it what, S. Okay. And now if I say you that this is a 90-degree angle. So can you tell me what is the value of angle in red? This is just a fun example. If you get this wrong, it's completely fine. Don't worry about it. Don't stress over it. But try to find the angle in red. Think about.
It'll be 90 degrees.
Okay, Mr. Dwayne says it's 90 degrees. I'm waiting for Mr. Riemann and Miss Tiffany. Yeah, so this is 90-degree. And how did we know this? Because we knew that the angle between PQ and R is equal to 180 degree, and I have made this line and I say that this is 90, hence I know this is 90 as well. Perfect. Everyone wrote this perfectly because this will be really useful for you in future. Yes, Miss Tiffany, please go on.
Because I know you said when it's flat it's 180.
Yeah. So you
When I
subtracted 90, right?
mhm. So
Perfect. This will be, yeah, you were saying, sorry.
no, I was just trying to make sure that the reason why
Yeah,
because
yeah, yeah. You solved it correctly. So you subtracted 180, you subtracted 90 from 180, right?
well I knew it because I was looking at my notes too.
Yeah, so yeah, you,
If it was the other way around, it'd still be 90 degrees.
yeah. So yeah, so that's it. You got the answer right. Yeah, and this is the correct way. Yeah.
Okay.
Okay. So my point is that whenever we find this, yes, Miss, someone was saying something, Mr. Raymond. Okay. Okay. So what we do here, so if I find lines like this which make 90-degree angle with each other, this lines, okay, suppose I extend this line further, this is a ray, Q and S is a ray, right? So if I extend this further and forever and ever, this will be a line, right? So let's call it T. So now ST is a line and PR is a line too. So, and this lines make 90-degree angle with each other, right? So this is 90-degree angle with each other. So we call this line as perpendicular. Now this is a big spelling, so pardon my drawing. Perpendicular. Woohoo! Shout out for me. Collinear line. Yeah, okay, Miss Stephanie. So, what collinear means is sharing a line. Whenever, so we only define points as collinear. So S and T are collinear, yes. S and Q are collinear as well, but the line ST and the line PR are known as perpendicular lines because two lines cannot share a line, right? Because line is a line, so this will be confusing. So we say perpendicular lines. Okay, I hope do you get it. So we always define the collinearity between points. Okay, so I hope you everyone can read this spelling perpendicular. Now we were talking about something interesting. Yes, Miss Stephanie, please go on.
I'm really acting like Miss. Okay, so is it PER, right? Per is PER or P?
It's
The word.
PER.
Oh, okay.
Yeah, yeah. So I'm sorry for my drawing skills. I should have practiced more, but yes. Okay, I'm sorry, I moved it. So it is perpendicular. Perpendicular lines are those lines which make a 90-degree angle between each other. And how we see the angle, we take a point, and how we calculate an angle between any line. Suppose now if we have two lines like this, and I say find the angle between the lines. Okay, so what you can do is, so take a point in this line, take a point in this line, find a common point, and this. Now we can name them as, this is A, the common point is B, and another point is C, so we can call it angle A B C. And whenever such ABC is equal to 90 degrees, we call the lines to be perpendicular to each other. Okay, so this is how we found the angle RQS, and the angle RQS was 90 degree. So I said the lines are perpendicular. Yes, you were saying something, Mr.
Okay, so
Smith?
that's still perpendicular lines that you just drew.
Yeah, those were perpendicular lines that I drew. Okay, so I can draw them again. Okay, I can't draw them again, but yeah, I can draw them again. Yeah, so these lines are, they look like perpendicular, right? Because they have a L like shape in them, so they are perpendicular, right? So if I say, but because ABC can be anything, but when I say you that ABC equal to 90 degree, then you are 100% sure that yes, those lines are perpendicular, right? Now we were discussing about railway tracks. So there is an important aspect of railway tracks, right? They never meet. So this is an example of railway tracks, right? So they never meet with each other. So whenever two lines never meet, we can extend this for, because a line goes on forever, right? I can extend the line till forever and ever and ever, and when I'm sure that these lines do not meet, I call them parallel lines. So you can extend this line forever and ever and ever, and these lines will never meet with each other. Okay, never cross with each other. So these lines are known as parallel lines. This is P-A-R, and I have to confirm the spelling because it's confusing. P-A-R-A-L-L-E-A. So this is parallel lines. Okay, so that's it for today. I hope you all understood what we learned today.
Yes, I learned a lot. I
Okay.
remember from me being in school, kind of.
Okay, so that's good. So let me just take a quick recap of what we learned, because it will be easier to. Okay, forget about. So a point is defined as just by simply writing out. If I want to define a point, I will simply write it as just the letter, just the alphabet, and that will be the point. A line is defined by writing two arrows. The arrows means that this line will go on forever and ever. A line segment is a part of the line, and it have a fixed value. This QP have a fixed value. The distance between Q and P will be fixed. It will not go on forever and ever. and it is defined by making a fixed line on QP. A ray is defined as something which have a starting point but will go on forever now. It starts from Q but it will go on forever, and how we name it is we find a point in the ray and we call it QR, and then we make a ray on top of it. Okay? And then we say two points are collinear when they share a line together. So here Q and R are collinear, Q and P are collinear, P and S are collinear, but Q and S are not collinear. We call the angle, how we find the angle is we find a point in a ray, then a common point, then a point in another ray, like angle DRM or angle MRD. Here the angle RPS or angle SPR. We say an angle is greater or less than some angle by looking at how much they are open, how much their mouth is open. Okay, and the sum total whenever we make the notebook, flip, when we make the front page touch to the last page, the total angle is 360 degrees. And we find the angles by looking at them. So this is 90, it means the outer angle is 270. How? Because I subtracted it with 360. Then we saw three type of angles: right angle, acute angle, and obtuse angle. Right angle is equal to 90 degree, acute angle is less than 90 degree, and obtuse angle is greater than 90 degree. And we saw two types of line, perpendicular and parallel lines. Perpendicular lines are those lines which make an angle of 90 degree with each other, and parallel lines are those lines which never meet. So to end this, I have a funny meme to share with you all. Before then, does anyone have a doubt? Can raise their hand.
I'm good.
Okay, now meantime.
I'm good.
Okay, so I hope we can see the meme soon. Okay, I don't know why it's not. Okay, let's see if I can share my screen with you. Okay, I hope you all are able to see my screen. Okay. Okay, so this is the meme. I said put it in the oven at 120 degrees.
I can't see your screen. Oh, there it is.
I hope you will be able to see my screen in soon, because it might take some time. So this was the joke. So the mother was saying it about temperature and the student got it.
They need you for a teacher with that one.
So you always have to know what degree we are talking about. So yeah. So
Turn the oven on.
Yeah.
That's funny.
So Mr. Dwayne, are you able to see the meme now? No? Okay,
Yeah,
no. Okay, that's good.
Yeah, I see.
So that's it for the class, and I hope you take care of yourself and have a good day. And if you have any doubt, please let me know. Okay?
Thank you.
All right. Thank you. You all have a nice day.
Bye, everybody.
Thank
Thank
you.
you.
Bye bye.
Everybody
everyone.
stay safe.
Bye.
And you all stay safe out there.
Sure,
Take
yeah.
care of yourselves.
All right, yeah.
Until tomorrow. Bye bye.